Hi everyone, welcome to Algebra 2, Lesson 2-5, Example 2, understand the process of completing the square. So in this example, we're going to think about how to understand why we're doing completing the square and why it works. So first of all, we want to see it visually. And before that, we also want to look through the vocabulary completing the square and what that means. So your quadratic equation or expression is not always going to be perfect square trinomial. Actually, it's mostly just not going to be, and it is special because it rarely happens. And so perfect square trinomial is what makes us easier to factor out, right? But even if we don't have perfect square trinomial, we can use the method of completing the square in order to make a perfect square trinomial partially so that we can factor them out and solve. So completing the square is the process of finding the constant to add x squared plus bx to create a perfect square trinomial. Let's see how that works. So look at this model here. X squared plus bx is right here, right? So x squared could be represented as an area for a square that has the side of x. And bx could be represented as the rectangle that has a side of x and a b. Okay, in order to complete the square, if we add x squared and bx, it is not going to be a square, it's going to be a rectangle because bx is a rectangle, right? So we can cut this in half, and then we can put it over here on the right side of the x square, and then on the bottom of the square that we have x squared. And then we just need a little bit of a square here in order to make a perfect square that's added to x squared, right? So we want to figure out what side does this little tiny square has, right? So whatever this side is, it'll make a perfect square for our addition problem, right? But we already know because what do? We split this in half vertically, right? Bx. That means we split b half. So this side is actually going to be b over 2. This side is also going to be b over 2. And we still have the same height, which is x. Does that make sense? So if we put the rectangle on the bottom, that means we have b over 2 here and x over here, and that matches, right? And so that means this one side of each side of this this square remaining that we're missing is just going to be b over 2, right? So b over 2 times b over 2 is b over 2 square. And so this area is b over 2 square, right? So we're adding x squared, we're adding b over 2x, which is twice. And so that just means we're adding bx. And x squared plus bx was the original expression we had, right? But in order to factor this, we have to make a complete square. We have to have a perfect square. So we're going to add b over 2 square to complete this perfect square, but we're also going to subtract b over 2 square in order to balance our equation where we don't change our expression x squared plus bx, which was our original one, right? Yeah, so now that we have this, we can use the perfect square trinomial and factor them out to get x plus b over 2, all of that squared. Okay, so this is why it works visually. We can model it using the area model. Part B, write x squared plus x 8x plus 5 equals 0 in the form x plus p all over that square equals q. What does that mean? We want to factor this out to a perfect square trinomial, make it to perfect square trinomial if it isn't, and then factor it out to a perfect square. And then that may not equal to 0 if we make it a perfect square trinomial, right? So we'll have a constant q. So first of all, you're going to see the original equation and see what we're missing. In order to use the completing the square method, this is not a perfect square trinomial, first of all, right? So in order to use this completing the square method, we're going to get rid of the constant that we have. That means we still don't want to change our equation. We have to balance it, right? So we're going to subtract 5 on both sides, and then we're going to add b over 2 squared on both sides of the equation so that we're not changing, right? And then we're going to factor that out. Does that make sense? So we're going to first subtract 5 on both sides. Then we're going to add 16 because that's b over 2 on both sides. B over 2 squared, right? And then we're going to add them to the same equation, to the same side, so that we're not changing equation. And then now this is a perfect square trinomial, and so we can factor it out using our perfect square. So x plus 4 would be a perfect square equals, that squared would equal to 16 minus 5, which is 11. And then we can solve x plus 4 is equal to 11, which will be x equals 11 minus 4, 7. But we're not asked to solve for x or solve for 0. We're just going to write this in the form x plus p squared equals q. So now we have x plus 4 squared equals 11, which is in this form exactly. So you can stop there. Okay. Let's look at try number 2. Now it's your turn. How can you write the equation x squared minus 6x minus 11 equals 0 in the form x minus p squared equals q? So again, you're not asked to solve for x yet, but you're going to change this to this form where you have a perfect square squared equals a constant. Okay, so use the method that we looked at in example 2. Pause the video and see if you can come up with your answer by yourself, and come back when you're ready for answers. Okay, are you ready? So how did you solve this? So first of all, you write the original equation, right? Try number 2. X squared minus 6x minus 11 is equal to 0. This is not a perfect square. So you're going to add 11 on both sides to get positive 11 on the other side, right? And then we're going to make this a perfect square trinomial. In order to do that, you want to figure out what b over 2 squared is. b is negative 6. So negative 6 over 2 is negative 3. Negative 3 squared is 9, right? So x squared minus 6x plus 9 is equal to 11 plus 9. Now we have a perfect square trinomial on the left side. So then you're going to use perfect square trinomial to factor it out. X plus 3, actually x minus 3, because you have a b that's negative. Squared. So negative 3 times negative 3 would be 9. Negative 3 plus negative 3 would be negative 6, right? Is equal to 20. And so that's it. You don't need to solve for x yet. You just need to write it in this form. X minus 3 squared equals 20. Okay, that was try number 2, example 2. We'll continue with the next example in the next video.